Dimension. Dimension of a physical quantity means the power to which fundamental quantities are to be raised in order to represent that quantity. Okay, so dimension of a physical quantity means the power to which fundamental quantities are to be raised in order to represent that quantity. Okay, so first of all, the most important word which we come across out here is fundamental quantities. So what are fundamental quantities? Let's revise. Fundamental quantities are those quantities which are independent of one another. For example, length, mass, time, electric current, okay, luminous intensity, temperature, quantity of matter. Altogether there are 7 fundamental quantities. Okay, so let us revise once again. Length, mass, time, electric current, luminous intensity, quantity of matter, and temperature. Apart from that, there are 2 special fundamental quantities. Okay, angle and solid angle. Okay. They are also independent of one another. So what we basically do out here, we basically give power to these fundamental quantities 1, 2, 3, 0, etc. and get another quantity. Okay, we give power to the fundamental quantities and get another quantity that will be the dimension of that quantity. For example, let us give one example out here. Okay, before giving one example, anything to the power 0 is 1, 2 to the power 0, 1, 3 to the power 0, 1, x to the power 0, 1. Anything to the power 0 is 1. Okay, this is very important for us. We need this. Okay, now let's carry on. So what I was talking about was, yeah, fundamental quantities. I was giving one example. Suppose we have taken 3 fundamental quantities m, l, and t. Okay, look at this bracket. We represent dimension within the bracket. Okay, so there are mass, length, and time. Let us give power 0, 1, and let us give it -1. Okay, now we have given power to the dimension. Sorry, we have given power to the fundamental quantities. Now m represents mass, l represents length, t represents time. Okay, so anything to the power 0 is 1. So m to the power 0 is 1. What is this? Length to the power 1 will give us length. T to the power -1 means it will go to the denominator by time. What is length by time? This distance by time equals to velocity or speed. Okay, so we give the power to the fundamental quantities and we got the derived quantity, which in this case is velocity. Okay, suppose we give mass 0, L1, T -2. Suppose let us give it also. Let us give mass 1, L1, T -2. So we are giving these 3 fundamental quantities the power. The power for mass is 1, the power for length is 1, power for time is -2. Okay, so mass into length or distance by time square. Okay, so first mass into length by time is velocity, so we get velocity by time equals to mass into velocity by time is acceleration, so mass into acceleration is force equals to mass into acceleration. This is the dimension for force. So if we give power 1 for the mass, power 1 for the length, and power -2 for the time, what quantity will be deriving? We will be finding the dimension for force. Yeah, this will be the dimension for force. So does this definition satisfy this example? Let us check. Dimension of a physical quantity means the power. Okay, power to which fundamental quantities, okay, we are giving power to the fundamental quantities, are to be raised in order to represent that quantity. Yes, we have represented different quantity out here, we have represented different quantity out here. This is the dimension for velocity, and this is the dimension for force. Okay. All right. Now let us learn how to find dimensions. Okay, let us find dimension for few cases. Let us find dimension for acceleration. Okay, first of all, to find dimension, we need to know the formula. What is the formula for acceleration? Acceleration equals to velocity by time. Okay, acceleration is velocity by time. Velocity is displacement by time. Already there is another time there. This velocity means displacement by time. This time is already there in the denominator. Okay, now let us put the dimension. Displacement is length, so L, time is t, and again another time t. Okay, now let us put it in the form of dimension. Don't forget this bracket. L, when this t and t, first of all it becomes L by t square. Okay, L by t into t is t square. So to write it in the form of dimension, L is here. Okay, mass is, okay, L is 1, mass is 0, there's no mass, so let's write on 0. T square will go up and become t to the power minus 2. Don't get confused with this m to the power 0. Okay, generally we represent dimension in the form of length, mass and time. That's why m to the power 0 is 1, so it doesn't have any significance out here. m to the power 1, t to the power minus 2. Okay, let us find for force here. Now let's find for force. Force equals to mass into acceleration. Mass is m. Acceleration we got lt to the power minus 2. So for force, m lt to the power minus 2. Now let us do for work. Work equals to force into displacement. Okay, work equals to force into displacement. How much we got for force? M L t to the power minus 2. And for displacement is length, so L. Now m is only 1, m, L1 and 1. M L square t to the power minus 2. In this way you can find out the dimension for many other things. Okay, try to find out dimension for energy, momentum, viscosity, coefficient of viscosity, Planck's constant, gravitational constant. Okay, if you have any confusion, you can write down in the comment. I can help that out. Okay, now next we have classification of physical quantities on the basis of dimensions. Okay, classification of physical quantities on the basis of dimensions. Let me write this first. Classification of physical quantities on the basis of dimension. Okay, before doing that, let us discuss what two things. Okay, first of all, what are variables? Variables are those which continuously changes, which keeps on changing, or which does not have definite value. Variables are those which does not have definite value. For example, does length have any particular value? No, it can have any value, isn't it? That's why length can be taken as variables. So another will be constant. Another is constant, which does not change. Okay, length, it can have any value. It can be 2 cm, 2 meter, 3, 4, 5, 6 kilometer. Okay, it can have any value, but constant means those physical quantity which does not change. For example, number 2. Number 2 is a fixed quantity, isn't it? It does not change. Another one, let's write down pi. Pi always has a fixed value, it does not change. The value of pi is 3.14. Okay, it is always 3.14. The value for pi is always 3.14. So these are some examples of constants. Okay, this length, volume, okay, mass, all those are variables. Now let us go to the main topic. Our main topic right now is to classify different physical quantities on the basis of dimension. Okay, our first one will be non-dimensional, okay, variable. Our first one is non-dimensional variable. Look at this, non-dimensional variable. First of all, variable means which is this. What type of variable we are talking about? Non-dimensional means which does not have dimension. Okay. Example, we have plenty of examples. Let us give one example. Non-dimensional variable. Okay, let's give this example. Angle. Okay. Strain. They don't have dimension, but they keep on changing. They does not have fixed value. We don't have fixed angle, isn't it? Angle may change. Strain. Okay. So non-dimensional variable means those variable which does not have dimension. Next one. Dimensional variable. Now those variable which has dimension. Okay. Plenty of examples. Length, mass, volume, etc. These are the variables which have dimension. Okay. Now next we have non-dimensional constants. Next we have constants which does not have dimensions. Okay. Example 2, 3, pi, etc. Okay. These are the constants which does not have dimension. They don't have dimension. Okay, but they are constant. They always have fixed value. The last one we have is dimensional constants. Dimensional constants. The constants which have dimension. First of all, let us give the example which you have already studied in class 9. I hope you remember this gravitational constant. Okay, its name itself says it is a constant, gravitational constant. It is a constant, okay, because it has a fixed value, but it has a dimension. It has a dimension. Next one is Planck's constant. You learn this in higher classes. Higher classes means you learn this year only. Till now you have not learned about this, I guess, or maybe you have. Okay, but this H is Planck's constant. Okay, E equals to H mu. E is energy. Okay, let's write like this: energy, and mu is frequency. H is Planck's constant. Okay, so this Planck's constant also has a fixed value, but it is a constant. So these are the four categories of physical quantities on the basis of dimensions: non-dimensional variable, dimensional variable, non-dimensional constants, and dimensional constants. Next is our principle of dimensional homogeneity. Okay. According to principle of dimensional homogeneity, dimension on the left hand side of the equation must be equal to the dimension on the right hand side. According to principle of dimensional homogeneity, dimension on the left hand side of the equation must be equal to the dimension on the right hand side. Suppose I have one dimension. Suppose I have an example, equation. X plus 2b equals to 3c plus z. Suppose I have equation like this. So according to principle of dimensional homogeneity, dimension of this side should be equal to dimension of this side. Okay, dimension on the left hand side of the equation should be equal to dimension on the right hand side of the equation. then only the equation will be correct. Okay, so in this context, let us also understand. Look at this sign. There are two plus signs. Okay, so it also explains us one thing. Two quantities can be added or subtracted only if the dimensions are same. Okay, only if the dimensions of two physical quantities are same, then only they will be added or subtracted. For example, I'll give you one most common example. Suppose I give one question: add 2 kilometer and 3 kg. Yeah. Add 2 kilometer and 3 kg. Will we be able to add them? No, because 2 kilometer plus 3 kg. We cannot add them. Why? Because kilometer is for length, kilogram is for mass, and length and mass are different dimensional quantities, so we cannot add them. Can we add 2 second and 3 centimeter? No, we cannot add, because they are different quantities. They have different dimensions. So only those quantities can be added or subtracted which have same dimension. For example, we can add 2 kilometer plus 3 centimeter. Why we can add 2 kilometer and 3 centimeter? Because kilometer is also length, centimeter is also length, so we can add them. Okay, we can add 10 kg and 30 grams, because 10 kg is also mass, 30 grams is also mass. So what we can understand from here is, suppose in this equation, let us look at this equation. In this equation there is a plus sign out here and plus sign out here. What does it indicate? It indicates this and this have same dimension, because they are being added out here. This and this have same dimension because they are being added out here. Okay, let us do one example. Let me first draw this. Right, I need to look at the question. If the distance traveled by an object is given by, if the distance traveled, if the distance traveled by an object is given by x equals to a plus bt plus ct square. If the distance traveled by an object is given by x equals to a plus bt plus ct square, find the dimensions of a, b and c. We have to find the dimensions of a, b and c, where out here x is the distance, x is distance, t is time. Okay, this is given. If the distance x equals to a plus bt plus ct square, find the dimension of a, b and c, where x is the distance and t is the time. Okay, now we have to find the dimension of this a, b and c using this equation. We know only the dimension of x, it is a distance, and t, it is a time. Okay, so first of all, let us use the principle of dimensional homogeneity. According to principle of dimensional homogeneity, dimension on the left hand side of the equation is equal to dimension on the right hand side of the equation. Let me put it like this. Dimension on the left hand side is equal to dimension on the right hand side. What is in the left hand side? Distance x. Okay, so left hand side is distance, so on the right hand side is also distance, because principle of dimensional homogeneity says dimension on the left hand side should be equal to dimension on the right hand side. So if this is distance already given, if this is distance, the one on the right hand side is also distance. Okay, so therefore x equals to a. We have to do this turnwise because there is a plus sign in between. We'll first do only with a. X equals to a, dimension of a is L. Therefore first let aside x is distance, therefore dimension of x is L. Okay, this will be our first step. Let me note this first step. Given x is the distance, so the dimension of x is L. Okay, Given t is the time, therefore dimension of time is t. Now let us proceed to the problem. So from this what we can get? We can get x equals to a. Therefore dimension of a is also L, because dimension of x we have already got is L from a. Okay, now we will go to another. Since this and this is added, means this and this have same dimension. Okay, again x equals to bt. Therefore b equals to x by t. X is length, t is time. So it becomes lt to the power minus 1, and lt to the power minus 1 is velocity. Okay, therefore dimension of b we got is lt to the power minus 1. Now let us do for c. Again x equals to ct square. Therefore c equals to x by t square. L by t square equals to lt to the power minus 2. This is acceleration, isn't it? So a is L, b is lt to the power minus 1, c is lt to the power minus 2. We have to do this twice because there is plus sign in between, which means this are added. Okay, so this dimension and overall this dimension and overall this dimension should be same. But our question is asking only a, b, and c. So I hope you understood this step. Let us do one more example to be clear. Let me draw this first. I suggest you want to check the syllabus first. Okay, syllabus of your class level, whatever board you are joining in. Now next we have van der Waals equation. Okay, van der Waals equation for a real gas is given by P plus A by V square B minus B equals to RT. What should be the dimension of A and B? Okay, so this is a van der Waals equation. This is a real gas equation. Okay, this is a real gas equation. We can also call it as a van der Waals equation, and it is P plus A by V square V minus B equals to RT. Okay, where I is a constant, T represents temperature out here, but we are not worried about this side. Okay, in this equation we have to find the dimension of A and B, but we are not worried about this equation. We can solve it from this side only. We can solve this. This is a very important question. Okay, this is one of the most common question, and the one which we have done before this is also one of the most common question. These two are the most common questions to be let's say like that. Okay, so in this particular problem we are not worried about that side. Let's come this side. P plus A by V square. We have to find the dimension of A and B. But what is given? P plus A by V square is given. Look at this sign, very important out here. Since there is a plus sign, we can easily understand the dimension of this and dimension of this should be same. That's why there is a plus sign. Since there is a plus sign in between, we can easily understand the dimension of this P and dimension of A by V square should be same. That's why they are added. So what we can add? We know dimension of P and dimension of P and dimension of A by V square is same. So let's put the dimension. P is okay. P is pressure and V is volume. Okay, so pressure equals to A by volume square. We have to find the dimension of this A. So pressure is force per unit area. Or let us do this in a simple step. Okay, pressure is force by area equals to A by volume square. Force is mass into acceleration, or okay, we have already got the dimension for force. Force means mass into acceleration. Area means length square. A is already there. Volume means V cube square. Most of you get confused out here. I have seen that most of you make mistake. Okay, because volume already has dimension V cube. Volume is, area is length square. Volume is length cube. So there is mistake out here. Actually it is L cube. Okay. So area is L square. Volume is L cube. But this volume also has square. That's why for L cube we have square. Okay. Let me write it in square bracket. Alright. Or A is in the side only, no problem with that. Mass is 1 m, L is 1 out here, there is 2. By the law of indices, it will go up and get subtracted. So L minus 1, T minus 2. This will multiply out here into, now it will become A to the power 6 equals to A to 6. Okay. Now A to the power 6 is there, M minus 1 is there. According to the law of indices, they will add because both of them are numerator. Why it was subtracted? Because it was in denominator. So when it went to the numerator, it got subtracted. But in this case, both of them are in numerator. Therefore, let me write it out here. M 6 plus minus 1, 5, e to the power minus 2. This is the dimension for A. Okay. Now we have to do for B. Again, V and B in another column. Okay. Dimension of V equals to dimension of B, because V and B are getting subtracted. Therefore, dimension of V and dimension of B is same. Therefore, dimension of B means L cube. Very simple. So the dimension of B is L cube, and the dimension of A is M, A to the power 5, T to the power minus 2. Right. Now let me do this. Now next we have uses. Okay. Uses of dimensional analysis. Right. Uses of dimensional analysis. Where dimensional analysis can be used. Okay. What are its applications? We'll do that one by one. First of all, first use or first application is to check the correctness of equation. This is use number one, to check the correctness of equation. So using dimensional analysis, we can check whether the equation is correct or not. Okay, using dimensional analysis, we can check whether the equation is correct or not. Let us take any random equation. Let's do one equation from class 9. V equals to U plus A T. Let us assume we don't know whether this equation is correct or not. When we did this in class 9, when we did the 3 equations of motion in class 9, we blindly believed that these equations are correct. Okay. Now since we are in class 11, let us check whether this equation is correct or not. Okay. Now we will not believe anything blindly. Okay. Now we are learning physics. We'll first check whether it is true or not. Then only we will believe. Okay. But someone has given this equation. Let us say someone has given this equation to us, and it's our duty to check whether it is correct or not. Okay. So I can take the help of principle of dimensional homogeneity. If this equation satisfies principle of dimensional homogeneity, then only this equation is correct. Okay. As simple as that. So first, let us find the dimension of left hand side. Okay. dimension of left hand side of the equation. What is there? V. In this case, V is the velocity. Velocity means distance by time. We don't have to do this again and again. We know now with the dimension of velocity is lt to the power minus 1. So the dimension of LHS is lt to the power minus 1 because it is velocity. Now let us find for RHS. Dimension of right hand side. First, there is u. We will not do this all at once. Why we will not do this all at once? Because there is a plus sign out here. So first we will do this side u. First there is u. lt to the power minus 1. Since it is velocity, I will write it directly now. Now we can write the dimension of velocity directly. We know it now. It is lt to the power minus 1. U is initial velocity, v is final velocity. After both are velocities, so u is lt to the power minus 1. Number 2, what do we have? At. A means acceleration, t means time. This is the dimension of acceleration. This is the dimension of time. Okay. So L minus 2 plus 1, accordingly this is minus 2 plus 1 is minus 1. Okay, minus 2 plus 1 is minus 1. So look at this, left hand side lt minus 1, right hand side first lt minus 1, right hand side second lt minus 1. So this equation is dimensionally correct. So now we can say that this equation is true. Okay, now this equation is true. This equation is correct. Let us do one more. Let us do another one equation. S equals to ut plus half at square. Now let us check whether this equation is correct or not. Till now we don't know whether this is correct or not. Now we have to prove it. Okay. Dimension of LHS. Dimension of LHS, first of all, there is distance. Okay. Since S is distance, therefore dimension of S is L. Now we do dimension of RHS. Now right hand side. First term is ut. First term is ut. Okay. Now let's write the dimension. U means velocity, lt to the power minus 1, but nt is time, equals to minus 1 plus 1, 0. So we will not write. What is the only one remaining? L. Okay. Second term, half a t square. Half a t square. Now half is a constant, dimensionless constant, it does not have dimension, so we are not worrying about this. A is acceleration, lt to the power minus 2, t square is time square. Now minus 2 plus 2, 0. Accordingly these two will be added because they are both are numerator. Minus 2 plus 2 will become 0. So what is only left? Length is only left. So for this L, for this L, for this L. So all of them have dimension L. So this equation is dimensionally correct. Okay. So you can learn from these examples and you can prove many other equations. You have come across many examples and you can prove it one by one. Okay. That will be your task. So we have finished one usefulness or one application to check the correctness of equation. Okay, these are the applications of dimensional analysis. Number 2 is to change the system of unit. Okay, to change the system of unit. Suppose one unit is given in SI system, or we can convert it into CJ system. Okay, we'll do that. And this is use number 2 to change the system of unit. Let us give one example directly. Change 5 Newton, not dyne. Change 5 Newton into dyne. Now this is our next use of dimension analysis to change the system of unit, and we are taking one example to change the 5 Newton into dyne. So to do this problem, we have to understand what we are dealing with. What we are dealing with? We are dealing with force. How do we know? Newton unit of force, dyne unit of force. Okay, we are dealing with force. So let us write on the dimension of force. Force equals to mL t to the power minus 2 mass into acceleration. So this is the dimension of force we have. Okay. Now for Newton side. Okay, for Newton side, N1 equals to 5. For dyne side, N2 equals to, we don't know. How many dynes we have to find out. How many Newton? 5. Okay. The value of Newton we know 5. How many dyne? We don't know. That's why square. Now M1. Okay. Mass, not M1 but mass equals to M1 kg. L equals to L1 meter. T equals to T1 second. First I'll write an experiment for it. M equals to into gram. L equals to L2 centimeter. T equals to T2 second. Okay. What I am doing out here is we are dealing with force. As I said already, we are dealing with force. So we have written the dimension of force, mL t to the power minus 2. So we have three fundamental quantities out here: mass, length, and time. Okay, we have mass, length, and time. So that's why I have taken this mass, length, and time. But for Newton, this is SI. That's why mass will become kg, length will become meter, time will become second. Dyne is CGS. That's why mass will become gram, length centimeter, and time second. Okay. Now open your dimension homogeneity. Left hand side and right hand side should be equal. Okay. But here what we will do? N1 M1 L1 T1 to the power minus 2 equals to N2 M2 L2 T to the power minus 2. See, this is for left hand side for SI system. This is for CJ system. Okay. What I am trying to find out? I am trying to find out N2. So let's keep it in one place. N2 equals to N1 will be outside. M1 by M2. I'll separate it. L1 by L2. T1 by T2 to the power minus 2. Okay. I'm finding this. I want to find the value for this N2. So this will go down in denominator. M1 by M2, L1 by L2, T1 by T2. Okay. Or N2 equals to N1, the value of N1 is 5. M1 is sorry, I made a mistake. Okay, let's do small correction. Our correction is in this way also we can get answer, but okay. M1, L1, T1, let us write it out here. M2, L2, T2. Now it's alright. Okay. Now it's alright. Now what is M1? M1 is, let's put the value of M1, M kg, M Let us do it in step only. They cancels out. Okay. Now or N2 equals to 5 kg will change into gram. Okay. Before doing that, M and N cancel. L and L also cancelled. Okay. So kg means 1000 gram. Already there is gram. Meter means 100 centimeter. Already there is centimeter. Gram cancelled. Centimeter cancelled. Now or N2 equals to 5 1 2 3 4 5 zeros. So we write down 10 to the power 1 2 3 4 5. 10 to the power 5. So the value of N2 is 5 into 10 to the power 5. So 5 Newton equals to 5 into 10 to the power 5 dyne. So we have converted it from Newton to dyne Newton. I hope you understood this. Let me do it on revise it. We have to convert 5 Newton into dyne. Okay. So Newton and dyne is force. So we wrote the dimension of force mft to the power minus 2. So we need mass, we need length, we need time. So n1 is 5 already given. N2 we have to find out for time. So mass for Newton m1 is m kg because it is SI. Length is in meter. T1 time is in second. Out here it is in gram. This is centimeter, CGS second. Okay. Now n1 into m1 l1 t1 to the power minus 2 equals to n2 m2 l2 t to the power minus 2. We need into, that's why I am taking it down. n1 m1 by m2 l1 by l2 t1 by t2 to the power minus 2. Okay. Now m1 is in kg, m2 is in gram. Okay. Now after putting that value, we will cancel whatever cancels out and we will get kg gram. Now this kg equals to 1000 gram and this already gram, so this two cancels out. Meter is 100 centimeter, this already centimeter, this two cancels out. So 1 2 3 4 5 t to the power 5. So 5 Newton equals to 5 into 10 to the power 5 times. You can do this for other examples also. Now let us go to the last use number 3. Okay, next number 3. To derive relation among various physical quantities. Okay, this is our third use in the last one. To derive the relation among various physical quantities. Let me get the question. Question is, what is the question? Yeah. Okay, the question is, the centripetal force depends upon mass, velocity, radius. The centripetal force for an object depends upon mass, velocity and its radius. Okay, find the expression for centripetal force. Find the expression for force. Find the expression for centripetal force. Okay. Now what are given? Mass, velocity and radius. Centripetal force depends upon mass, velocity and radius. Okay. So what depends upon mass? Force. So force is proportional to given. Force is proportional to mass, m, velocity, v and radius r. Okay. According to the question, to force depends upon mass, velocity and radius. Okay, we have to find its expression. So let us write A, B and C out here. Okay, force is proportional to mass to the power A, velocity to the power B and radius to the power C. This we have to do in every problem of this kind. Okay, we have to write A, B and C. Okay, now let us remove this proportional sign and let us keep one constant, or F equals to K. If we remove proportional sign, we have to keep constant. Okay, m to the power A, b to the power b, r to the power c. Okay, now let us apply dimension. Now after applying dimension, it will become okay. After putting the dimension, force ml square, no, not m square, force is mass into acceleration, ml e to the power minus 2. Force is mass into acceleration equals to constant does not have dimension out here. This is mass, so m to the power a. V is velocity, m to the power minus 1 into b. R is radius, whatever it is. Radius means length to the power c. Okay, continue observing what I have done. Centripetal force F depends upon mass, velocity and radius. Okay, so that's why it's proportional. Mass I have given power A, power B, power C. It can be any order, no problem with that. But A, B and C we have to write down. Okay, now let us remove this proportional sign. To remove this proportional sign, we keep constant. So F equals to K, m to the power A, b to the power b, r to the power c. Now let us put the dimensions for this force. This K doesn't have dimension. Mass m to the power a, velocity, the dimension for velocity is 80 to the power minus 1. B, r is radius, radius is length, so L to the power c. Now let us compare the comparing dimension on LHS and RHS. Let us compare dimension on left hand side and right hand side. So let us first check with m. In LHS, what is the power of m? The power of m is nothing means 1. Okay, the power of m is 1. So we will have 1 equals to, already the power of m is a. Let me repeat. Now we will compare the dimension of left hand side and right hand side. We will be comparing the power along with the dimension of left hand side and right hand side. So let us first go with m. Out here the power of m is 1. This will be 1 out here equals to, out here the power of m is a. So 1 equals to a. This is very important for us now. Now let us go to L. In left hand side, what is the dimension of L? The dimension of L is 1. So we write down 1 out here equals to, out here the dimension of L is B. But there is L. Again there is one more L. We write down plus C. Okay. Out here 1 B plus C, because this is also L, this is also L. So L has B plus C. We'll keep it like this only. Now let us go for T. For T the power is minus 2 out here equals to, for T out here is minus 1 into B is minus B. Minus 1 into B, because we have only one T out here. Out here T, the value of T, power of T is minus 2. Out here the power of T is minus 1 into B is minus B. Minus minus cancels out. What is the value of B? The value of B is 2. The value of A is 1. We'll put the value of B from here to here. 1 equals to 2 plus C. Therefore C equals to 1 minus 2 equals to minus 1. The value of C will become minus 1 from here. Okay. Now we'll put the value of B and C out here. Okay, we'll put the value of A, B and C out here. Putting the value of A, B and C, that is equation 1. In equation number 1, we put the value of A, B and C in this equation. We get F equals to K into the power A. The value of A is 1, B. The value of B is 2. The value of B is 2 and R. The value of C is minus 1. So we have put the value of A, B and C out here. Force equals to K into the power 1, B to the power 2, R to the power minus 1. Or F equals to K mb square, R minus 1 will go in the denominator and will become R. F equals to K mb square by R. This is the required formula for the centripetal force. Okay, this is the required formula for centripetal force, which we have got with the above dimension analysis. And now this K is important out here. We cannot find the dimension of this K, okay, the proportional constant, using this dimension analysis. To find this value, to find the value of this K, we can find only with the help of experiments. Okay.